Hunter,
Yes.
do you remember what direct variation is?
Yes.
What is it?
It's where of so as x varies, y varies, and use the equation y equals k times x equals constant.
Very good. That's exactly what it means. Okay? So as x gets bigger, it varies, y varies directly as whatever k is. If k is 2, whatever x is, y varies twice as much. All right? Notice there's no other constant on there. If you graph a direct variation equation, it goes right through the origin. Okay? So, take a problem where it says y varies directly. That's x. And y is, oh, I don't know, 16 when x equals -2. Let's find the constant of variation, and let's find the equation of variation. So if I know that y equals kx, and given the information that y is 16 when x is -2, I find that k is equal to -8. That's the constant of variation. That makes the equation of variation y equals -8x. Now that I found, because they're going to give you some information where you can find the constant. Then they're going to ask you about this equation. Find y, for instance, when x is equal to -20. So we take that direct variation equation, find y when x is -20, and we find that y is going to equal 160. Okay, we've done that before. So this section pretty much is the same process. Right? Direct variation. Now we have inverse variation. Direct variation. The number of chirps that a cricket makes varies directly as the, what? Who knows that? Okay. Maybe as what? As a temperature. So we can say the number of chirps that a cricket makes varies directly as the temperature, T. Okay? Now we can go out and test that. If it's 70 degrees, we can figure out how many chirps a cricket makes, and then we can find that constant. So no matter how many degrees it is outside, we know how many chirps per minute we can expect from a little cricket. That's an example of how it might be. Inverse variation states y varies, not directly, but inversely as x. Y varies inversely as x. And what that means, y equals, we're always going to have the k, the constant. But when you see that word inversely, it's a division. We put that x in the denominator. So y varies inversely as x, y equals k over x. They may give you the same information. First of all, they'll say when y equals 7 and x equals -2. Find the inverse equation. So we'll put 7 in for y. We'll put in -2 for x. And we find our constant would be -14. So the equation would look like y equals -14 over x. And you might get equation, we'll find y then when x is equal to positive 2. Then y would equal negative 7. Okay, get the idea? That's inverse variation. So we have direct variation, inverse variation, and one more. Joint variation. And the words might say y varies jointly as, oh, let's say x and z. Y varies. I'm going to have my k. We have either inverse variation, direct variation, joint variation. You're going to have a constant. So y varies jointly as x and z. So it's x times z. Find k if x equals negative 3, y equals 4, or not y, z equals 4. And y is equal to, I don't know, negative 108. Right. Find the constant of variation, find the equation of variation. This is joint variation. So negative 108 equals k times negative 3 times 4. I have negative 12k equals negative 108. And I find that my constant of variation is 9. And in this particular problem, y equals 9, x, z. Now that you've done that, it's going to say find y when x is, find y when x is 3 and x is negative 7. So 9 times negative 7. Oops. That's when x is 3 and z is negative 7. So 9 times 3 times negative 7. And so y would equal negative, I don't know, 189 maybe. Is that right? All right. Now combination. How would you write this? Y varies jointly as x and z and inversely as w. How would I write that?
Y equals X.
Go ahead. Y equals?
K, X, Z,
Yeah. Whenever you see that word inversely, the next variable you see goes in denominator. So y is equal to kxz over w. And the same process we've had before. They're going to give you values for x, z, w, and y in order to find the constant. And then use that equation to find the missing variable y. Okay? Is that clear? All right. And basically that's what this first section is about. The rest of this chapter I hope you like factoring. Not only are we going to factor, but we are going to put these polynomials into fractions, rational polynomials. We're going to add them, subtract them, so it's like adding and subtracting fractions, multiplying and dividing those fractions. Okay, there's 8 sections in this chapter. It's quite lengthy and it's quite involved. All right, so enjoy this one today. Today and tomorrow is not too bad. Yeah.
What would you say is the first chapter?
I think this chapter's challenging. Yeah, and only because there's so much to remember. And I hope you guys like to memorize. As we get to the trig part of the course, there's a lot of memorization. It's just the way it is with trig.
When do we start?
Okay. Your homework for today. Page 486 and 487. 14 through 34 evens. And a couple of story problems, 43 through 46. All. Okay?